Technology. Oh no, I just technology. Hello, everybody. Hello, Matt. How are you?
Doing great. How about you, Bill?
Oh, I'm hanging in there. I'm hanging in there. It's been an exciting week. For those that don't know, we have a very special guest today. Matt Liberty is with us, creator of the Joulescope. Though you didn't create the Joule itself, right? That's named after somebody else. Oh, we've got Ben is joining us.
Oh,
Hey, Ben.
hey, Ben.
Excellent timing.
I'm in my, I'm sorry, I'm in the car. I lost track of time dealing with bureaucracy this morning. Paperwork for a contract customer of mine who is using every little hoop.
Well, we look like we lost you as you turned on to, this is where I'd make a joke about the highway system if I knew it out there. So, anyways, you didn't invent the, hey, Ben, can you call us from the, you're breaking up real bad. Can you call us from the office?
No, it's because I drove away from my house and my Wi-Fi connection dropped.
All right.
I will be at the office in about 5 minutes, and I'll just mute and let you guys carry on.
Okay, very good. So, anyways, tell us about the Joulescope. What is a Joulescope? What is a Joule? What is all this stuff about energy? And why isn't energy an amp? What's all this going on here?
Yeah, so Joulescope is a product. We have a new one that's coming out here, the JS220. It measures on the front here, measures current. Oh, let's see, hold it up there. Measures current and voltage. And from there, it computes power, which is current times voltage, energy, which is the integral of power, and also charge, which is the integral of current. So joules is the SI unit of measurement for energy, just like watts, amps, and volts are the other measurements for the other fields. And this instrument is really made to help you measure high dynamic range currents, which is a big problem right now with modern electronics, which vary from microamps when they're sleeping or in this down state, and then when they wake up and go to sensor readings and RF transmission can draw amps even or tens of milliamps for Bluetooth, hundreds of milliamps for some other technologies and Wi-Fi, and even an amp for some of the larger M1, so cell network stuff. So this product is really made to help people optimize their products and have them either have longer lasting batteries or smaller batteries.
So would you say that the battery market is the primary place where you, and that's not how I used it, and we'll talk about how I used it, and I banged on the input and output of a switch mode power supply with mine, and just I had a blast doing it.
Oh yeah, no, the people use it for that. I think the majority of people are in the IoT battery, powered space for my customers. But I have customers that use it to do, much larger systems and things where they care about energy consumption, especially, for regulations like TVs, an Energy Star, they have to turn off even when they're on, right, and consume lower energy. Looking at current and anything you'd normally have a current probe for, you can use the Joulescope for. I've even had people use it for scientific. So where you normally would have an electrometer, people have used Joulescope to measure nanoamps and done that accurately enough. It's not going to be as good as your many tens of $1,000s electrometer as far as measuring picoamps, but it can definitely measure nanoamps.
So the challenge that if I were to wrap up what you just said is the high dynamic range. That's what I heard in that, is how do you measure nanoamps, picoamps, and then turn on the product and still tell us what the current is, right?
Yeah, I mean, you think about like most oscilloscopes are 8-bit.
Yes, recently, they are. Yes, they are.
there's been a push towards 10 and
14,
12, and 14 even, but you look at their actual effective number of bits, they're still 8, 10, maybe. So that's kind of what you get out of an oscilloscope, and that precision, you're talking 256 at best, 16,000 range of their dynamic range. So if you're measuring a nanoamp, that means you measure up to 10 microamps. So that dynamic range can't even happen with a oscilloscope without a lot of extra work. The
Right.
multimeter side, even if you have a 32-bit multimeter, which, is not normal either. There are a few chips out there that claim to do it, but unless you do a whole bunch of extra work, the rest of the analog signal chain can't actually get you that 32 bits. But even if you do that, Joulescope has more range than that. So it's about 33, 34 effective bits of dynamic range,
Wow.
because it's able to switch between its own ranges so quickly without missing any measurement. It can give you the appearance of that effective number of bits. So
Right.
almost 10 orders of magnitude.
It's like an f-stop for a camera, only it's for the amplifier in this thing. It gives it incredible dynamic range.
Exactly.
Is what I'm hearing.
Yep.
Now, do you chopper stabilize or anything? When I hear you talking about switching, I'm like, oh, and I want to ask you how you do the switching, but it sounds like, well, I might as well look at a gain reference and a zero reference at the same time while I'm doing that and null out drifts in my amplifier.
Yeah, so I do use a chopper op amp up at the front of the signal chain. It's for the original JS110, we used one that had some really bad artifacts. If you hit it hard, it would just
Right.
go and do a square wave oscillation. With this one, we chose one from TI that's much better behaved under all circumstances. So yeah, we have our first stage is a chopper op amp, and the reason for that is that it can actually be temperature stable over over a very wide
can breathe
temperature
on the
range.
board, basically.
Exactly. Yeah. So our maximum burden voltage, which is the voltage between the plus side and the minus side of the current measurement, is 20 millivolts over the shunt resistor. So if you're taking 15 bits, because we're 16-bit ADC, half of that ends up being lost because it's plus and minus. So it's 15 bits. So you're dividing by 32,000 for that. So
Right.
we care about microamp, less than a microamp. And really the only way to get that stability is with a chopper op amp.
Right. So you didn't do the chopping. You got a chopper op amp that already does. Now, when you do your switching, what do you use to gain switch?
Well, let's see if it'll actually tune in enough here. It's small. Yeah, so right up here, if you look closely, those are our MOSFETs,
Right.
that are selecting our shunt resistors.
With the
which is
guard
the
fence
lineup
around them. Yeah.
Exactly. Yep. So those MOSFETs are what select each individual shunt resistor, and our shunt resistors range from 10 milliohms all the way up to 1 kiloohm.
So you built your own switches.
Essentially, yes.
Yeah. Yeah. Very cool.
And the problem with MOSFETs, for people that haven't played with MOSFETs, is they have a lot of strange behavior when you really start caring about things. So they have essentially capacitors everywhere.
Yes. Yeah. I was just about to say. So usually an electronic switch, and I'm thinking like, I go back to the Harris days, DG201 and things like that.
Mm-hmm.
When you charged a node, they would turn on another FET to discharge the node at the same rate, right?
Mm-hmm.
It was all about when you turn things on, you get this thump, this DC bias change. Did you have any of that problem?
Oh yeah, so that's another name for that I know is charge injection.
Yes.
Right? So yeah, when you turn on the gate capacitance for the FETs is pretty big, right? So
right.
When you turn them on, that capacitor has something on the other side. So the electrons and they have to meet up. So whenever you power up the gate or power down the gate, you have a corresponding change on the source or drain. So yeah, we definitely paid a lot of attention to that to make sure that the amount of charge injection was balanced out. Now we don't do an exact, 1-for-1 balance like you're talking about,
right?
But we do have. We paid a lot of attention to how fast we switch that gate, and also where that charge is going. In the design, we make sure that it's very all as you can see, there's a lot of attention paid to layout up here. That's a very layout critical area. So it's not just that you put down some MOSFETs on a board and be done with it. You have to think about a lot of how the real world parasitics affect things.
Right. Yeah, I did instrumentation in the 70s, and oh my gosh, we had to work so hard for 16 bits. We had dual slope integrators that took a quarter second to do it. And the one thing I noticed, you guard ringed that not most people, it's easy to do it wrong. You need to know what you're doing to do it right, to guard ring parasitic, or you create parasitics when you do that. It's my understanding.
Yeah, you can easily add more capacitance. It's always easy to add capacitance.
And then it becomes, well, what's on the other side of the capacitor? Ground? Is it really? It's ground's
on your
frequency. Yeah, ground's an opinion to me. It could be like a loud ground, a quiet ground. It can be outstanding in your backyard, and be a significant potential difference than what you think. Right. Which is a great segue for USB grounding. We should work our way into that.
Yeah,
hey,
or
Ben,
isolation.
How you doing?
Yeah.
All right. I had just going back. I know I missed a couple of minutes there. For people who have not ever used them, what is a chopper op amp?
So chopper op amp. Normal op amps, you have two signals coming in, one to the plus terminal, one to the minus, right? And you have some amount of gain, in the ideal case, infinite, that is amplifying that, right? With the chopper op amp, you actually have a feedback loop that is taking a look at the bias of each of those inputs and nullifying it essentially at some frequency, so that your entire system bias is low. So nothing's perfect, right? So with a normal op amp, you may have 100 microvolts or even millivolts of difference on those terminals that are a bias that you just have built
input
in.
Offset. Yeah, because of input offset current and various other differences in the silicon.
Yep. And with the chopper op amp, it actively cancels that out. Now, bad chopper op amps introduce as many problems as they solve. Because you end up having frequency dependencies
and the little charge injection noise
but these ones actually are pretty nice. So TI makes a number of them depending upon your bandwidth, and characteristics that you need. And I've been very happy with them so far on the JS220.
Excellent.
Yep. So what'd you end up using for? We haven't talked about it outright yet, but for the analog to digital converters, is that a Delta Sigma, or what is that you're using?
It's a SAR, so just a normal sampling.
Successive approximation.
Yep. Yeah, so it's a 16-bit part, and actually we use 4 channels. So 1 channel for voltage and 3 for current.
Okay. Why 3 per current? Just less switching you have to do, or less critical paths?
So this is a new thing. So this is a new thing with the JS110. We actually just had 2 channels, 1 for voltage, 1 for current. With our new JS220, we have something that we're calling Enwavify, which is a technology that is essentially sampling the 10 milliohm resistor all the time, and then a much faster convergence on the other one for range changes. And then we use signal processing to fuse that together so that we get accurate measurements even through the current range switches.
Wow. Wow. And that's probably something you had to learn your way up to. Like, did you envision doing that on your first rev of the part?
No, the JS110, and when I started, no way. Yeah, no.
Right. That sounds pretty sophisticated. Yeah.
Yeah, I mean, the JS110, and just like the JS220, switches super fast, right? So if you have a current range change and you have a spike in your system going from microamps to amps, it switches in 1 microsecond or less.
Right.
However, with the JS110, it took about 5 microseconds for things to settle out, and you have this blind spot in the JS110. And we did some processing to go over that. And for most systems, it actually doesn't really matter when you think about percentage of error in that. But it was always a concern. So with the JS220, we solved that.
Very cool. Very cool. So I actually have the screens for 2. So we're talking about the JS110, the JS210, but I don't remember if we talked about what those were. There's a difference in time, right? But you showed us the 210. The 110, well, I've got one of each running here on my bench. And let's add it to the stream.
Ooh.
And what I'm going to do is turn on my load. And you can see in one screen here, I'm able to plot the efficiency of a switch mode power supply. I have the JS 220. I was calling it 210 earlier. On the input, and you can see the voltage dropping. What I'm doing is I'm pulsing a load between 0.1 amp and 3/4 of an amp on the output of this. And what we can do that's real cool, here's the whole reason we can do this kind of thing, is thanks to the GUI, I can zoom in and deal with this high dynamic range and see my answers. I can see the Ben, we're getting a lot of echo, I think.
There shouldn't be now.
All right, thank you.
Sorry.
But we can see that this is not oscillating right when the load hits. We can see a lot of things here. But to me, the fact that I could take a seldom occurring event and scroll in and see to this degree, this, congratulations. This was definitely a home run in my book.
Awesome. Well, thanks. Great that you found it useful for this. It's one of the things that's totally different from an oscilloscope is that it's always on, right? So you're always collecting data. So this is important for a lot of customers doing things like, Internet of Things devices that may be off for hours and then all of a sudden turn on, and you can capture everything, the entire total energy consumption over that entire window. So it's really made for that. And that's a huge difference between something like an oscilloscope and Joulescope.
That's the benefit of using software on a desktop or a laptop as well. You have basically unlimited memory compared with an oscilloscope.
Well, we can do a pretty good job trying to fill it up, though.
Yeah, if you're doing that high resolution data
problem.
Yeah. I mean, we do allow people to reduce their effective sampling rate. So we do downsampling. So if you don't need all that data, you don't have to record it all. But at the full rate, we're basically a little over 8 megabytes per second, which is a terabyte a day, roughly.
Well, what I like here is right down here in the corner, there's a W. And that's reading out in watts, which you can't get off an oscilloscope without teaching the oscilloscope some amazing tricks. Not amazing tricks, but it's got to take time. All these things.
Yeah, you have to jump through hoops and use the math menus and
Mm-hmm.
Yep. So where'd you get the idea to do a Joulescope? How'd you go? The world needs to be able to measure energy.
Well, I've been designing products for a while and come across the same problem. How do you measure current into something? Everything from so I worked at a company where we did a lot of battery powered stuff, and energy and battery size was important, but we never really had great tools to help with that.
Right.
Even on USB projects. So I'd done a few USB projects, just measuring USB inrush and then getting down to your suspend mode current. There's no easy way to do that. Even just multimeters, even with the range of that, was a challenge. So you could do it, but not
it's
great.
Measuring current, let alone current in a DSO environment where you want to go back like you did and expand time and
exactly. So I finally I was looking to do a product. So I had started consulting back in 2011. And by the time 2017 came around, I was thinking about different products. I had a few on the possibility list and decided to tackle this problem. It's something that I'd had. I talked to a number of people. They all had similar problems. And actually, after launching this, I've talked to people like, I was about to build a product like that once. And it seems to be a common problem that people face, but there's really no great, affordable solution until Joulescope.
Yeah,
that leads to another question. Interesting, I have for you too. Like, you actually bit the bullet and did it right. I think a lot of people, and I've thought of this problem too. I've even thought of the same problem of an LCR bridge. A lot of people want to measure inductance, so they're like, well, all you have to do is apply a fixed voltage, and then you know,
Pick the phase angle
capture the current waveform, and then, you know, you do your differentiation and you get your inductance value, right? Or you can work it out from frequency and resonance. Everyone who's studied electrical engineering knows these things in principle are on paper mathematically quite easy to measure. So why is it hard to get test instruments that do it? Why do they not exist? Or if they do, they're expensive. Until you actually start building it and actually getting, like, doing the work to make sure the results are accurate and that you can trust them and use them in a proper lab environment, people don't realize just quite how difficult it is. I think it's very brave to go into metrology. Very brave. How did you
or foolish?
Well, how did you overcome that? Because you probably got to a point in the first rev when you were working on it where you might have been rethinking your idea to go into this. Like, you might have been doubting yourself, or
were you getting the results you expected?
Like, how did you traverse that? Like, that's a big river crossing in my book. Like, my hat's off to anyone who's done that.
Yeah, and I think the way that I approached it was not that I was committed to this idea initially, but I had to prove to myself that I could do it. And that process took a while. And at the same time, I hadn't stopped consulting either. So this was initially a side project that, you know, I was not dedicating a lot of time to, but I happened to have a little downtime, and I chose not to fill it with clients at the time. So end up just spending time on my project and kind of treated it just like I would any of my other consulting projects, you know. So I had goals and milestones and things that I was trying to produce along the way to demonstrate, you know, feasibility. So yeah, it wasn't something that one day I said, I'm just going to do this and it's going to be, you know, full in. Over time, I kind of built up a confidence that it was going to work. Something I can share, there's a picture here that might be interesting. Let me see if I can share my screen.
Had you seen other models working of it, just not as good, or people talking about the concept of doing it this way?
So I hadn't really, there wasn't really any other equipment that was affordable, you know. So you have the expensive $10,000 pieces of equipment. There's been some other things that have come out right about the same time at some various price points that are similar but different. But there was nothing really when I started this in 2017. It was at this affordable level.
Okay, so you invented a feature versus cost level here.
Essentially, yeah. So one thing you can see if you post my screen up here.
Alrighty.
So this is from the Kickstarter page. This is the whole series of prototypes, and actually there are some that are missing from here that I went through from initial concept, which was over here. And can people see my cursor? Yeah, they can.
Yep.
Yep. So the initial concept up here that I really didn't care at all about form factor, is just whatever was easy, trying to prove that it works. You can see I had some big issues in that
alpha level stuff. Yes,
exactly. And then by the time I was getting over towards here, I'm like, I'm done. I'm putting in a case. Yeah. And then all these followed.
You know, I talked with Lemore from Adafruit, and she said that she uses PC board color to tell her where she is in the design cycle. And it's almost what it looks like you have there. I see greens and then purples and then red. And
yeah, it's not quite that well selected.
Right. But, but it reminded me of that, your little rainbow there.
Yeah, so I think the first ones here were all PCB way. And then I moved over to Osh Park, you know, the notorious purple. And the reason for that is that PCB way, PCB way couldn't really do the 4-layer and BGA that I wanted reliably. And they kicked me over to their high tech process rather than the low one, and it ended up being just as long and as costly as Osh Park. And Osh Park is way better quality. So
Osh Park are amazing. I love those guys.
Yeah. I do too. I have like tons of little boards, you know, all around here, you know, that are Osh Park boards because it's just awesome. And then the red is Macrofab. I was going towards my alpha there, and then You can see all the joys of figuring out that rails need to be rails.
Chassis ground or at least grounded or not grounded, not sometimes grounded.
Exactly. So that's what the Kapton tape's for, if you can really see the little yellow on the edge there. And then blue was our beta unit. And then the production units are all green again. So we do have beta and green for the production and beta, blue and green, sorry. But everything else was rather happenstance.
So you mentioned your rail, and I've done that. Like, here's a rail, and I intentionally left it actually with a tinning, so it would pick up the edge of the PC board.
Yep.
So what's your grounding scenario? You've got isolation, you've got a USB ground. You know, I couldn't even find in the USB spec if you're supposed to ground both ends of the cable. The old, you know, a guy that used to design instrumentation says never ground the shield on both ends of a cable, right?
Yeah, and there's a huge debate
real far in USB land.
Oh yeah, in USB land, there's a debate that it's essentially settled by my cable. So apparently, my cable attaches shield, ground, and ground. So it really is a moot point at that point. But on the
not all cables do.
Well, no. It's supposed to be the original USB spec.
USB-C.
There's a shield. There's supposed to be a shield that is separate from the actual digital ground.
Right.
But a lot of modern cables just don't do that, and you know, that couldn't be a compliance issue. You know, if you're emitting, fortunately, we passed you know, Class B emissions, so it obviously wasn't an issue with the cable.
Right.
But yeah, on the Joulescope side, we could very well just short them together, but we actually have an AC term, so we have a cap, and then 200 some K, 200 some K ohm resistor. Right.
So I go back to the old rule. The axiom I was taught as a youngster was where there's no current flow, there's no radiation. So that's why us old time guys don't like to ground both ends of a cable, is you can't get current flow if only one end's grounded. Now you can't do magnetic shielding if both ends aren't grounded. You know, so it's like everything. There's trade-offs.
That axiom is what trips people up when they're really getting into electromagnetics.
Yeah.
Like,
so what you doing there, Ben? You just opened yours?
Yes. I'm unboxing my beta unit. Thanks, Matt, for sending me this. This is a brilliant, very nicely made piece of gear. This is something I really love about this, though, and what I was looking forward to using for projects and testing out these trigger or other inputs. How can we use these? Because I have this notion that one of the benefits of this is this will actually modify my software. This will cause me to make changes to my software in an embedded system in order to reduce and optimize power. Yeah.
When you're doing certain things in hardware where it's an interrupt routine or you just hit a point in time, is that what you're after, Ben?
Yeah. So it looks like I can use these for external triggers and other event capture. And then this the JS220 came with this test board that has a Raspberry Pi 2040 on it. That's very cool. And the necessary cables, the board's nicely labeled so we can see where we need to plug things in. I can't get my camera to focus on that, but this tells you what digital IOs to loop this back to for testing. So walk us through some of the things that this is designed to do.
Yeah, so the most common is actually just isolating a region of interest. So if you have a microcontroller that is asleep and you want to just focus on the time when it wakes up, then the first thing the microcontroller can do when it wakes up is toggle a GPIO or turn it on and leave it on, and then turn it off at the end of that region of interest. We actually have a script. All of our host side software is open source. So we have a script that people use that actually can just capture those regions of interest. It's not built into the UI today, but for an automated test setup, which is what a lot of people use this for, you can actually just collect that region of interest and you get your energy or charge, whatever you're interested in, and without any extra work with that GPIO.
That's brilliant.
Yeah.
And of course, there is a separate trigger input as well. So this is probably the more traditional way we'd look at doing things like this.
Yeah, and that the way that trigger's set up, it's more intended for other test equipment, whereas the GPIO are super high impedance. They are still USB ground referenced, so if you have a more complicated setup, that can be an issue. But they are designed to be super high impedance. So most digital inputs are, typically, microamp or so.
Yep.
Of leakage, sometimes a little bit more, which for a lot of my customers, that's a problem, right? So if you're trying to measure sleep current down to 10 microamps and you just connect up a couple IO, now you've just thrown off your reading. So
You killed the cat.
Oh yeah. So these you actually use very high impedance comparators for the inputs rather than normal digital logic. So it makes sure that your leakage current's super low.
Was that Schrodinger's problem, Bill? He didn't have enough. He didn't have a high enough impedance for the box the cat was in?
Cat. Yeah. The impedance interface killed the cat. It collapsed his little wave function. So show the carry case that your thing came. The Joulescope for me was one of those things where I enjoyed the cardboard box it came in as much as I enjoyed the toy. It was
this is really cool. Was this unique to the JS220, or did the earlier model have one of these as well?
So the JS110 did. That was kind of a last-minute addition for the JS110. We did it right as the Kickstarter was closing, actually. The reason is I was looking at packaging costs, and I'm like, I could put it in a nice branded cardboard box, or I could get that. So I decided to go for that because
Isn't
it's
that
actually
interesting.
Oh yeah, it's more useful, and I found an awesome company on Alibaba. What is it? Shenzhen P&H Tech Core. They ended up doing a great job both on the JS110 and on the JS220 carry cases. And yeah, it's a little bit more than a cardboard box, but it's not.
It's worth it.
That much, exactly.
It's absolutely worth it.
So how'd that work? You went on Alibaba and looked at people who were advertising one-off things, but with the interest of, hey, we can do this custom. Is that
exactly
how it was from the start?
Yeah, so I didn't know exactly what I was looking for. I'm not a mechanical engineer and didn't know the types of cases, but I looked, you just go on there and look for people that have done that offer custom cases and that look good and don't look too cheap. So it's kind of like all those things together. And, with that kind of metric of an approach, I found a bunch of people on Alibaba to source different parts of the Joulescope stuff. And just reached out to them. They provided a quote. I provided them a drawing of what the inside was going to be for the cutouts.
Well, I was wondering, I could picture you doing that in Fusion 360 or something, or even a simple drawing.
Yeah, actually, the first one was an Inkscape because that's what I had at the time for the JS210 or 110. The JS220, I did a little bit better drawing because I actually had the full model of that device at the time.
Right.
The JS110 was a little more rushed, but they did a great job. They took my drawing, made it a real drawing, and built this EVA case. And with the JS220, I learned that we'd want to have a pocket, so we didn't have that initially.
Yeah,
and a zipper.
It's really, really good. Nicely done.
Yeah, thanks.
Sometimes those little things, and if they're there and they're done well, people don't even actually notice them.
Mm-hmm.
Keeping your vital test leads with your test equipment that's more than just a nicety. That's like I need
essential.
to know they're not falling out on the floor when I open it. Yeah.
Otherwise, they end up with the rest of your test equipment and are gone forever, right?
Right. Oh yeah. I'm a witch's hat fascist. I'm like, that witch's hat, if it comes off, it goes on a certain part of the bench, and because I just hate losing ground clips and things over time. Yeah, absolutely. What else so you end up using Alibaba as a broker service, as we used to in the old days. It used to be, well, how do I find several people doing overseas sourcing?
Well, I used to use global sources, but didn't they end up as Alibaba or part of Alibaba? Do you remember that? Back in the late 90s, early 2000s, it was Global Source or Global Sources, something like that.
Yeah, I'm not
Maybe
sure.
that became Alibaba, because I wouldn't even see that it's still around now. But
Guy, remember the Thomas Register? We used to, the big green books. If that's how you advertised in the U.S. was you put your product in Thomas Register. So cool. So as you put this together, when did you know that, hey, this is, did you hit your sales goals? I guess that's what I'm trying to. Did you get the reception that you had hoped for when this thing was just a twinkle in your eye?
Yeah, so with the JS110, so it was a 2-year roughly development cycle from start to finish, maybe a little bit more even, because I think I did start a little bit in 2016, so it's been a while. But yeah, the initial Kickstarter, we set a goal, and it was like that Kickstarter curse. We just hit the goal. So ideally, you'd want to go way above that or a little bit low. So that was like kind of our stress point. The whole idea with the Kickstarter is that we'd be able to fund our first build, not make any money off the Kickstarter essentially, but then make it off the remaining units.
How much was that Kickstarter?
96,000.
I was going to guess 100K.
Yeah, I think it was just under 100K is what we brought in. And then with pre-orders on top of that, we brought in another 10 or 20K. So not a huge amount. So initially it was enough to be a business, but not enough to repay the effort, not enough to, really be well off. But we got a great group of initial customers, and really a lot of that spread by word of mouth. So we kept growing and have reached a place where obviously it's doing well enough that I'm doing the second model.
Right.
So it's brilliant. Well, we're all better off because it exists. This is it is a very much needed product right now.
Do you foresee when you could have two of these talk to each other, like they would use a common trigger, one of those GPIO lines we talk about, and trigger two Joulescopes?
Or maybe the trigger? Yeah.
Or maybe the trigger, and a little T adapter.
Yep. That's the thought with this. So we have a number of people that actually use multiple Joulescopes. Our largest customer is very power conscious, and they have an entire setup. The largest they had were 40 Joulescopes instrumenting the same thing.
Wow.
So yes, we have some motivation to try to make that a little bit easier. So it's not something that's supported off the shelf with the Joulescope UI, but that's going to be changing over the next 6 months.
So I could imagine you doing a higher end or sort of different product tiers. Eventually this could grow to where you have those multi-channel versions, which could essentially imagine a rack where it's basically the same Joulescope, but it's plugged in like a backplane kind of thing, where you have multiple channels in a rack to go in, so people could use it in a factory environment.
Yeah, and if it wasn't so hard to build hardware these days, it might have already happened. But we definitely scaled back our ambitions with the components. Just building the products that we have has been hard enough. So we ran out of JS110 stock, not deliberately, but because we couldn't build them anymore. Back in June.
The last one.
It's been very rough for anyone that's been building hardware, and that's with us being diligent and ordering parts. But two of the parts on the JS110 are microcontrollers. One is a ST microcontroller and another is an NXP, and both of those are pretty much unobtainable. We placed orders back in April last year, or even March or April, and still haven't gotten a real good delivery date from anyone on those two.
It's
so it's
super
been brutal.
tough.
Yeah.
ST and NXP in particular are tough.
Yep.
That's why I actually have I don't use the word conspiracy with the word theory, because it's an oxymoron. Okay. But I have a conspiracy hypothesis that the Raspberry Pi Foundation had something to do with the chip shortage. No, I'm kidding. Of course, we all know it's because factories shut down and all of that, and it's the after effects. It's going to take a while for the waves to ripple out. But isn't it ironic that the RP2040 is plentiful and dirt cheap? When everything else became unobtainable.
Yeah, I mean, you already showed the EVK. I've also used them. They're awesome. So I don't really. I mean, this is a little test board for building Joulescopes.
I'm forming a new love affair with that chip. I never thought I would, because I had a bad taste in my mouth when the Raspberry Pi first launched, and they did all their marketing around it being open source, but it is certainly not open source. Only the software is, because they based it on Linux and Python. And so what they really meant was it's a closed source hardware platform with an open source software
Right.
on top of it, which is more honest. And I have a thing about that. But yeah, I got to say, what the work they've done with the 2040 chip is impressive. And I'm looking forward to them actually. I'm sure whatever comes next will be even more capable, so.
Oh yeah, I mean, already with what they have with dual core, Cortex M0 pluses, it's fast. I mean, it's not going to beat your desktop, obviously, but for doing anything like twiddling bits with the PIO,
Yeah,
it's pretty good. So I've used them to build a bunch of my test setup for the manufacturing test for Joulescopes, and it's so easy to get working. You just put on MicroPython, and you now have a full REPL that you can automate using Python on your computer. So there's the PyBoard script. You can just talk directly between them. So you have remote, access. So remote procedure call essentially for free over Python, and things that you don't care about performance, you can just issue from that REPL. Things that you do care, you can run in MicroPython on the board. So it makes it super easy to get things up and running quick and have enough speed where you need it for most GPIO like bit twiddling operations.
Yeah, it's pretty impressive given that you can get them for 80 cents for 1,000.
Jonathan just asked a great question. I was just about to ask it. So tell us about the two. Then I want to talk about FPGAs, but tell us about the two microcontrollers and what do they do on there?
Sure. On the JS220, we actually have one. Let's see if I can get it in the camera here. One right here. It's a little Cortex M7, and its main role in life is just to move data. So it moves data from USB over into the FPGA here and back and forth, and does the whole USB communication. But as far as what makes Joulescope interesting, it doesn't do a whole lot other than the communication.
It could though, like the M7 has some pretty significant DSP capabilities.
It does, yeah. And right now we're using that mostly just to shuffle data, but it could do a lot more there. But right now it's pretty busy moving the 8 megabytes per second of data back and forth.
Yeah, that's a lot. That's a lot.
So yeah, there is a little bit of headroom there. But when we put downsampling on the FPGA, which is what we're going to do, it's going to have a lot more headroom there. So I've thought about actually opening up, MicroPython on here exactly. It could run MicroPython. So I don't know, but right now it's just shuffling data. The other one is our FPGA here, and this FPGA has a bunch of things in it. One of them is a RISC-V. So the Pico RV32, which is Claire Zen's project. It's an open source RISC-V core, which is awesome. And we have some custom controllers in there which run a little custom assembly that do things like our calibration and statistics computation that just really didn't fit into the RISC-V core, along with some custom logic. So those are our two main processing blocks. And then we have a bunch of analog up here, as you see. And then our GPIO right there, which comes in through here, and power all on the top.
Right. So tell us about the FPGA then. So that's in the isolated area, as I learned. By the way, I flipped the board over and I go, oh, there's the ground split. Yeah. It's like right
it's
there.
Pretty obvious once you see that.
Once you flip the board over. Yeah. But so you use isolation here for between basically USB and the world, right? Or is that the wrong place to think of it?
No, that's the right thing. So we're separating USB ground from what I call the sensor, the instrument side that's making the measurements. Right. And that's a nice thing for a few reasons. So when you have isolation, you don't have to worry about current flowing. And when you're making accurate current measurements, that's a really good thing. It's really hard to do accurate current measurements without some isolation. You can possibly do it with some approaches, but with this level of bandwidth, it gets very hard. So we actually have the sensor side all isolated from the USB ground side. the way of doing that, right, with this is transformer, which we have up top, and then we have some digital isolators as well that use 2 of them that are capacitive, and one that is an old opto style to do the communication side, so that it's not fully isolated. We actually want to get data from the isolated side back, otherwise it's not very useful.
So you used a lattice for the FPGA?
Yeah, an ECP5.
All right, and why lattice?
Because they're inexpensive and good enough as far as the processing we need to do. Yep.
Yeah, actually, the ECPs are really well priced, given that they have hardware multipliers and all that stuff on board, right?
Yep. Yeah,
There's a lot you can do with those.
Oh yeah, and we use those very much. It has enough internal RAM also to do everything that we needed to do. So yeah, you can get much more capable FPGAs, but for us, this was good enough, and it was a huge step up. So on the JS110, we had the Lattice Ice family,
Right,
2 of them actually, and we ran into the limits of those. So we wanted to add more features and just really ran out of room and capability. So with
the target for ICE is really low power as well, right? That's why they gave them that name.
It is, but surprisingly, the ECP5 is pretty low power, compared to a lot of other FPGAs. So it's not quite like the ICE family, but it's not too bad. And it allows us to run on that isolated side with still meeting the USB 500 milliamp max, 2.5 watt envelope.
Yeah, that's great, and not needing heat sinks on it.
Correct. Yeah.
and you used Icarus Verilog as your main source.
Yeah, so Icarus Verilog with CocoaTB actually. So CocoaTB is a Python-based framework that allows you to write your tests in Python and talk to the simulator, which is Icarus Verilog, and have it all automated. So you're not writing your tests in Verilog, so most of my design for the JS220 is all Verilog, but while I know Verilog, I'd like to write as little as possible. So
writing HDL test benches is more time consuming than writing the HDL for the actual thing.
Exactly. And with the Python side for CocoaDB, it's actually pretty quick. So I've been pretty happy with that solution.
Yeah, my problem with test benches was it was always difficult enough. I end up struggling against the test bench syntax, as opposed to trying to think of every way I should be using the test bench to test my bench,
Yeah. And this is why there's big money in, commercially, this is why some of the big money in EDA tools is in actually automating all that stuff.
Right.
But it's, that was something I haven't looked at it yet, but that framework using Icarus Verilog with Coco and others, I listened to an interview on the Ampower probably a couple of years ago with a guy who'd used the Lattice Ice to make a very, whatever the smallest FPGA was available and cheapest at the time, a very small gumstick sort of board for people to get started using that, and it was sold on Tindy. I forgot his name, and I wish I remembered it because I'd love to give him a shout out. But that interview, he was discussing that CocoaTB. It sounded really, really productive.
Yeah, it does take a little bit to get used to, but it's not that bad of a learning curve. It's not like the FPGA Verilog learning curve, which I think for a lot of people find is pretty steep. And the project you're talking about, I remember his whole thing was an online system, wasn't it? And it was made to try to make it a lot easier to use that. But the learning curve of going just to CocoaDB, especially if you already know Python, is not so bad.
So Jonathan asked, can you simulate ECP5 for testing on the PC?
Yes. So I have a number of test benches. I'm much more of the unit testing approach and test-driven development side of things. So I have a test, obviously, for each block. But I also do have a system simulation for it, but it's pretty slow. There are other simulators, and I'm blanking on the name right now, rather than Icarus Verilog, that compile down to C and run much faster. I had a problem getting that working, so I've just stuck with CocoaTB and Icarus because it was good enough. But yeah, there are ways of making the simulation run a lot faster. And even my little, this is a ECP 525 that so it's not even the biggest one, but it takes a while to get anything done on the PC simulation.
Got. So Jonathan also asked the question you see before you about the Cortex M7 and why not one of the FTDI fixed function chips, assuming you could get them.
Right.
Maybe that's why.
Yeah, so I have a few things that make that a little more difficult. The isolation barrier is one. So I have to in this design, we have to control power over the isolation barrier and communication over it.
Right.
So the FTDI chips don't really have a nice interface that is good enough for going over an isolation barrier. And that's what we used the FPGAs in the previous, the JS110. We had one on each side. One of them on the sensor side was doing all the sensor stuff too, but they're essentially communicating over that isolation barrier. So I could have gone with that approach in an FTDI, but I decided to go with this Cortex M7, which we actually use its SPI hardware peripherals, 2 of them, to communicate over that isolation barrier and do that accurately. So the FTDI chips, yeah, certainly you can do that. I know a lot of people use them. The other part, if you get to a little bit higher bandwidth, are the Cypress parts, the FX2 and FX3. So those are, and I've actually right before I did this board, I did an FX3 board project as a consultant. So very familiar with those. But I'd also use this little micro, well, an earlier version of it, to do USB communications in a product. And this is Atmel, now Microchip. They do a great job on their USB peripheral. I was not overly happy with the JS110 USB. That hardware peripheral inside that microcontroller was a little more dodgy, whereas the Microchip Atmel one is very solid.
Yeah, and they have great library support too. Like I would argue that Atmel/Microchip probably is easier to get things working in software earlier than many of the others. The Cypress are pretty good too, because they've been at it for a while, and they have nice IDEs as well. I've used their PSOC devices for a number of projects over the years.
Yeah, it seems like every time I do a USB project, I just end up dumping my own stack on it because I always find I'm unhappy with the vendor provide ones. I mean, I've been doing USB stuff for so long. I have my own Chapter 9 thing that I use on a lot of projects that actually is reliable and handles all the bad things that go on. Whereas most of the vendor stacks, I found a problem with the NXP bootloader that I was scared that if it ever ran in the field, it'd just be
that you might end up with bricked products coming back to you.
Yeah. So yeah, you get different levels of maturity, I think, with some of the vendor stuff. There are definitely off the shelf purchasable USB stacks that are good, but it's not always easy to get something that is reliable built into your product without tackling some of the lower level issues and drivers and register problems that may not have been noticed for someone who's doing USB HID application when you go to something that's trying to reliably pump 8 megabytes per second of data over the USB port all the time, 24/7, months at a time.
Yeah, that is a big deal. There's so many assumptions in every one of these things that the original creators don't even think about.
Right. So the one of the ways you touched the customer was the web store experience, which I had a very positive. I was just borrowing a unit from you, and you treated me as a web store channel, and that worked because then I got the tracking notices and everything that says here's your products on its way and stuff. How'd you end up with I think you said Shopify? How is that? Is that what you'd recommend for people, or is that a heavy lift for a smaller project? Or
I would definitely recommend Shopify. So we initially started on Kickstarter. We went to use BackerKit to do our fulfillment, but then after that, how do you actually sell online? You could create your own store. You could use one of the online providers, and there are a few out there now. But Shopify for us was just super easy to get set up. And for a small company, they handle a lot of the steps. So they will send out emails when people purchase, right? They
Right.
handle the shipping somewhat, right? So they make it easy for you to purchase shipping and just directly out of the software. And they have a pretty nice interface and pretty customizable. So I've been pretty happy with it. They are not, necessarily perfect for large scale. I mean, we're not selling huge amounts, but as you get bigger, you start talking about other fulfillment routes, and they now have things that integrate into that. And they've definitely grown, I think, to make that even easier.
Right.
For us, where we're at, we're still doing mostly our own fulfillment. So it's still a great fit without any additional tools or integrations.
Right. Right before the show, you and me were talking about hand stuffing these. And that's the problem with talking before the show, is then I don't remember what we've already talked about or whatnot. But we were talking, you hand stuffed 0402 on these. You got to know the board up close and personal. Like you hand stuffed these BGAs, right? You got to watch the BGA settle, I'm assuming, right?
Yeah.
Tell us about some of the trials and tribulations of hand stuffing a board these days.
Yeah, so for starting out, I mean, this is about as big as I'd ever want to do for hand stuffing. But for smaller prototype boards, it's not so bad. You can design your board. This is the last one that I hand stuffed. I think all the other ones have been at my CM. Then you can order from whatever your favorite PCB place is. Osh Park is awesome. Then order stencils. So I use Osh Stencil in the US.
Yeah, I love those guys. I use them too.
They're great. Yeah, and you just get it back, place down the stencil, apply the solder paste. I just use what is it? It's just
a credit card.
It's a spatula thing, but putty knife. To apply the solder. I tend to get solder from Chip Quick. I know other people like other ones, but I use their shelf stable one because I don't.
Well, I was going to say what turned me off the Chip Quick is when I got a sample of it, it wasn't refrigerated, nor had it been refrigerated before it arrived at my place.
Yep.
So I didn't know what the shelf life was on it.
Yeah, and if you order directly from them, you get lot dates that are all new. They say it's fine for normal shipping, even for the non-shelf stable ones. But you never know,
especially sealed.
Yeah, if you never know if you order from DigiKey or Mouse, or how long it's been sitting there.
Exactly.
So yeah,
and you're pretty sure they don't keep them in refrigerators either.
No, they don't.
Yeah. So you get that. You apply the paste, and then tweezers and magnifying glass to apply the parts. This has 400 and some.
And you're a fellow AM scope fan. We were talking. You've got your.
I see that there.
Yeah.
Yeah, and then I use a hot air reflow, just a normal station with the IR heater to heat up the board first, preheat, and then manually just go over the board with the heat and see everything reflow. I've always thought about getting an oven, but I don't know, never done it.
They just take up a little more room. But I've used an oven for 5 or so years. I've got there's 2 different ones. Bill and I've talked about this because he has one as well, and his isn't very good. The heat is not even. It's a bit.
No, I've now it is my Control 3.
Well, that's the new one. That's the one you replaced it with. I'm talking about the one from AliExpress. The T5.
I gave that
or whatever it is.
Yeah,
those smaller ones, they're okay. They're okay if you're doing small boards and they're right in the middle. I went on one of my trips to Shanghai when I was working at Altium, and they were at Altium. Altium was at Shanghai. I took advantage of the situation and ordered a bunch of stuff while I was over there locally. So I got it at a better price and didn't have to pay shipping or anything, just took it back. So I got the bigger one with an A suffix, and it's been fantastic. The only downside is because I got it locally in Shanghai, it's
wrong voltage.
It's 220. So wherever I use it, I'm wiring in a 220 circuit, which that's not a big deal. I mean, we have that here.
So yeah, let's talk offline, Matt. I might be able to fix you up with an oven. I know a guy.
Yeah,
Like,
those
son makes them.
the controller with the what's the controller called again? It's Neo.
Control 3.
Yeah, Control EO3.
It's a PID controller, and
I
it
saw the
really
first,
does do the job.
I saw the first version of that at Maker Faire back in 2017, I want to say, and the designer of that as an open source product had a stand there and had all the gold foil lining in the toaster oven. Those do a fabulous job. You just have to put in a bit of effort to get it all set up.
Yeah, I was looking at that at one point, and I'm like, they do build them, so you can actually pay them more and get it fully.
Well, we buy the build kit from them and build them, and still earn our money. It's a 3-day process, but by the time you let the epoxy set and everything like that. But it's like anything too. You end up adding your own to it. We ended up getting our own parts, some of them, and expedite, streamlining the build process. So, and then the chip shortage happened. So cool. What didn't we talk? So did you write all the software in this? I'm assuming. So tell me, as we get near the end here, you've got all kinds of layers of software. You've got the GUI, you've got the USB driver. What all did you have to do to pull this off?
Yeah, so I mean, if you start from the lowest side, we have little teeny microcontroller firmware running on the RISC-V. There's not much code space in there. It doesn't need to do very much, but there's code there. Code on the other side on the chip here, doing all the USB stack and firmware. We have now a new driver in C, a user space driver that's using WinUSB on Windows and libUSB on Mac and Linux to talk to the device. And then we have the next layer up from that. We have actually compatibility wrapper. So our old driver from the JS110 was all Python. So we have a layer that makes it look the same if you want that. So that as far as someone who's coming from the JS110 can just keep using the same thing. And then we have our UI. We also have a number of other projects. So we have a server that people can use and have used, so you can run it on a Raspberry Pi headless and then get the data back to your PC. So those are all kind of auxiliary things. But yeah, so we have Python, we have C, and actually more C on the MicroPython on the microcontroller side. But yeah, it's what I did kind of as a consultant too. So I was doing a lot of embedded firmware. So it wasn't that big of a jump to do all that. I had the experience, and it's not something that you'd want to just jump in and do all of this, on your first project out the gate. Pick up if you're looking at this and say, how did he get there? It was not doing this like first thing out of school or in high school. It was lots of things over time and just continuing to learn new stuff.
Here, Jonathan's got another question here about USB VID and PID. Did you pay the piper?
I did not. So this is not USB certified. That has never been important to my customers. No one's ever complained that the JS110 was not USB certified. And the only reason that you need to actually pay the USB forum, is if you want to use the USB logo and USB branding. So if you don't care about that, everyone can implement USB, which is unlike some other technologies where you have to pay for the licensing. With USB, you can use it regardless. So I ended up getting mine from MCS. It's hold on, let me just tell you so I have that correctly. MCS Electronics, which I believe is a Dutch company that got their vendor ID before it was illegal to share them. And under Dutch law, unlike the US law, you can't amend a contract once it's been issued. So they can keep issuing product IDs for sale for people. And they're guaranteed unique. They're $15 each or whatever. And you don't have to worry about anyone else stomping on your vendor ID and product ID combo. But you don't have to pay the full USB IF fee either.
Wow, that's good to know. That's the kind of thing that I wouldn't know if somebody didn't tell the story.
Very good to know.
Yeah. And if you don't want to do that, if you're doing a project with like one of the vendors like ST or NXP or Microchip, they tend to issue, you can apply and they'll issue you a product ID out of their space.
Right.
If you're using their microcontroller, and usually it's only up to a certain volume, but for hobbyists or whatever, you can actually, or small makers, you can apply directly to the chip manufacturers too.
We had the same thing. I started an ISP years ago, and the same thing with IP numbers. You could get them from your carrier, or you could go get your own if you knew how. And it was all just a matter of knowing where to go, what seedy back room, back alley door to knock on.
Yeah, MCS Electronics, I've actually got the ones for the Joulescope, the JS110 and JS220. I've got some from other, smaller volume products for my customers back when I was doing consulting. And to date, we haven't had any issues, and it's been cheap. So as long as you don't care about USB cert, you can do that. As soon as you go USB cert, you have to have your own vendor ID.
Right. Do you still have that picture of your bed of nails tester that you had up the other day?
Let's see. I have it somewhere.
Yeah, I don't want to put you on the spot there, but
yeah, I have the
board
or
if you had the bed of nails tester.
Well, it doesn't have this. This is a board that doesn't have the bed of nails in it, but this is actual circuit board that is the plate that it compresses into. If you give me a moment, I should be able to find my pictures here. Let's see here. Might have to take this down. Let's see here. Just give me a moment here.
Sure.
It's I have to log into iCloud apparently. Of course.
Yeah, and then it'll update the software, and then
who knows? Yeah. All right, so it's logging in here. Let's see if I can find a good picture here of that.
And the challenge that I'm asking Matt about is, how do you test your something in production? And the range sits from it just sitting on the desk, and you look at it, to it telling you, yes, I'm working okay, or I'm working as okay as I can be measured, or I need to be put in a test fixture, and signals need to be picked up so that we can measure it and test to make sure we're okay. And it's that bed of nails tester where we hopefully we'll see a picture here where you pick up the pogo pins. There we go.
There it is.
Okay, yeah. So this, you can't quite see it here. These are pogo pins. So they're just pins on springs. And as you push them down, they compress. And here's our alignment ones on the corners. And the board, the JS220, fits right on here. And these are little, I actually have through hole, not just pads that they seat into really nicely. And on the back side of this board, I actually have a couple components to make it really easy to integrate and connect into my JTAG programmer for the FPGA and the SWD Sager J-Link for the microcontroller. What is not shown here is a whole bunch of test equipment. You can kind of see the back of it back there that is all responsible for calibration of the JS220 itself, including the Joulescope. So we use a Joulescope to test Joulescopes.
That makes perfect sense.
Yeah, for the we don't use that to actually calibrate it, but we use that to test that the USB current draw is within spec.
So what gets calibrated? What data gets generated for calibration? Are they basically gain constants and drifts, or not drifts, but offsets, or what? We
test. So I'm pretty paranoid. We test a lot. This setup is actually a lot faster than the JS110. The JS110 calibration took almost 4 minutes. This is down to less than half of that, but we test everything. So we test gains and offsets. We test a lot more than that. We test some response things. We test response over frequency, leakage. So part of this device is it has to be not consuming current, right? So there are definitely things that you have in test instruments, all test instruments that can conduct current not through the sensor of interest or the measurement of interest, but around that, using through parasitics and leakage currents. So it's actually extremely sensitive to any type of moisture or contamination or flux. So we have to do a really good job of cleaning. My CM knows all this and is on it. But we measure to make sure that that was done right, and we can actually, the station can tell when they have not cleaned it correctly, or waited long enough for it to dry. So those type of things all get tested here with the test fixture.
Wow. And there are times when a board doesn't need to be cleaned, but in this case, it needs to be cleaned, right?
This one definitely needs to be cleaned. When you talk about nanoamps, you can't have any flux residue at all on the board. In the critical sections, then, if it's on the digital side, who cares? No one's ever going to know. But if it's in that gate, the area where you notice that there were the guard traces, there's one area in particular that is very bad. If there's stuff there, just the impedance of the flux is enough to throw off the operation of the device.
Right. Which sounds entirely frustrating to work on.
Well,
go ahead, Ben. I'm sorry.
No, flux is not something included in the layer stack field solver softwares that cost thousands of dollars. They didn't.
You get that for free. That's for free.
Yeah. Well, I always model dirty flux. It's not just flux. It's flux with stuff stuck in it.
Yeah,
my head,
moisture
it's like a rare
and junk.
tar pit stuff.
Right.
Yeah, that was a super surprising thing to me. So I was doing a low power design, and just the flux leakage at one point, because we weren't getting the boards cleaned, was enough to be noticeable in the device's power consumption during sleep.
Wow. I hadn't thought of it in a power consumption frame of mind. Yeah. So
if you're doing really low power stuff, and I mean, if you're going down to like 0.6 volts, it's a lot less, proportionally less. But at 3.3 volts, it can add up, right?
Right.
Yeah, it's
for me,
crazy.
With range gauge amplifiers, that's where we had to be flux aware, and even the two dissimilar metals touching each other, like the leads, Kovar leads touching tin solder pads could create noise and stuff, as my memory.
Right.
So, excellent. Hey, what haven't we asked you? That this has been excellent. We've done well past an hour.
I want to know. What I wanted to know was when can people get their hands on a 220?
Yes,
I know it's currently in beta.
Yeah, so you can.
I'm lucky enough to have this in my hand now. But people are going to want this. Like, this is an indispensable tool.
Definitely, yeah. You can pre-order today. You just go to joulescope.com, joulescope.com, and you can pre-order today. We're shipping. Actually, we ship to our distributors today, and we're shipping to everyone worldwide on November 3rd.
Oh, so that's really soon, just a few days away.
Yeah, less than a week.
So this is so they can do their pre-order right this moment. Like, they could watch this video and do a pre-order.
They could, yes, right now.
Or if they get the video later, it's an order, not even a pre-order, because by then time will have changed.
Yeah, I'm going to put a banner up so people know where to go.
Yeah, well. I was looking for how to do the banner. I didn't want to accidentally trip the self-destruct sequence again. Those pesky things.
.com. And we're going to show that right now. So this is where you go.
Yeah, and all of our host software is all open source. So if you go to joulescope.com and you want to learn more about that, just click on that support tab, and we take you to all of our open source software. So it's a huge benefit compared to a lot of the other things that are out there, even at the much higher price points that are not open source. And this allows you to get really started right away, and not just use a UI, but also integrate it into larger test setups, which is very common for people doing low power design.
Right. Well, I want to give a shout out to Mike Fikes, who hooked me up with you originally. That turned out to be a great relationship. It led to us talking here today. So excellent.
Yeah.
Excellent.
Oh, yeah.
Thank you, Mike.
It's awesome. Yeah, he somewhere around here. Yeah, sent me one of his pulse loads as well that he's been playing with. And it's awesome to meet new customers that are super into things and know what they're talking about and are able to push things to the limit.
Yeah. Oh yeah, he's checking your math on the standard deviation right now, even as we speak. Yeah. Those MIT people,
Yeah, it's amazing how hard it is to compute standard deviation in real time.
Yep. So excellent. Well, I want to thank you again for coming on. I want to thank you for making the Joulescope.
Yeah, this is brilliant.
Yeah, it solved a problem for me in a way where I knew it would be the thing I needed to solve the problem. And that's, as I said, greatest compliment I can get was I sent you not a PO, but I bought one, so.
Well, thank you very much. Yeah.
Excellent. Ben, any last words? Or I know you're anxious to jump on
I just got all this going, and I'm very excited to use it on some projects moving forward and actually document the progress on videos and whatnot. So
yeah. Excellent.
Yeah, well, if you guys have any questions, feel free to reach out to me. For everyone that's listening, you can go to the forum at forum.joulescope.com. We have a great group there, and I tend to reply pretty quickly there too.
He does.
So yeah, just if you have any questions about whether it's Joulescope or just low power design. If you're getting started with the Nordic Power Profiler 2 even, and you're concerned about are you getting good measurements out of it, or are you set up right, it's a great place to ask those questions too.
Very cool. Very cool. Well, excellent. Well, again, I want to thank everybody for watching here today. It was a good show, and we talked about a lot: analog, digital, software, FPGAs, RISC-V, housings, ground. I mean, it just went on and
bit
on.
Of everything. Just like
much like
classic,
the product.
Classic Coriolis show,
Yes.
We cover a lot of ground. Sometimes we go deep, but usually we go wide.
Swirl around to say.
Today, actually, this is a great deep and wide episode because there is a lot of depth to what was discussed today.
Yep.
Something to learn for everyone.
So Matt, we'll have to have you come back when you're doing JS 3330 or whatever the next one will be called. Yeah, what is the next product? I've been, you and me have been talking a little bit. And I've been thinking, we got to get them to do some other things, but we'll talk offline about those.
Yeah, I have a few ideas, and I'd be a lot more eager about them if the component shortage was not so real.
Yeah.
Oh yeah.
Right now, I'm very happy to stick with the JS220 for a while and really dial in some features. So there's a bunch of features that people have requested that we're not going to have at launch time, but they'll be coming out, over the next few months, and really just over the next years even. I'm just making the JS220 even more usable. So we have a baseline set of hardware. There's a lot that we can do on the software side that we're super excited about.
Oh, just one other question too on that. It's like you've launched the product. Well, it's launching in a few days, so that's a big deal. You've probably put months into this. Are you full time? Are you full time on these products now, or are you still available for people to get help as a contractor here and there?
No, I'm not doing contracting anymore. So this is JS220, and Joulescope is now my full-time job.
You've made it.
Yeah, I know.
Well done.
My wife does all of our accounting, finance, business side, fulfillment, all of our sales, a lot of our sales support for placing orders. And
that is so good. You've totally made it. And with help with a partner that's not just a life partner. So
but now it's like Lewis Carroll, the faster you run, the harder it is to stay in place.
No, I have no doubt this is going to just lead to more and more great products as well. With what you learn putting yourself through a product development cycle twice now, with a product like this, there's so much you have that could be applied to other problems now. Mm-hmm. Just as like doing contract work for different customers, each time you're adding tools to your kit bag. So that's what led to the Joulescope in the first
Right.
place. And now, so I can only imagine there's going to be other great things coming down the line.
Yeah, right
Yep.
now I'm just looking for a little bit slower times. You know, the summer going into the fall has been, as you can imagine, launching a new product, a lot of work and a lot of hours put into it. So
Oh.
it'll be nice to have, hopefully, you know, not too many issues after launch. You know, relax for a little bit, get back to a normal schedule
No
before launching
drama
into
whether
something.
the PC board will work. That
Have
you're
some
about
actual
to
holidays
receive.
in the holiday season, perhaps.
Yeah.
Exactly. Yeah, the downsides of, you know, being your own boss is that you have to work for the jerk.
Yeah. Well, I call it the chief bottle washer, and people don't know what I mean till you own a business. And yep, if
I've heard
there's-
that phrase many times. Yes.
Yeah, and it's true. Nobody at I had 16 people, and I was the one that had, you know, that would clean out the sink.
It's like a family. I have 3 children who are constantly asked to do chores and clean up around the house, and guess who ends up still actually doing them all?
But the difference is you at least got to ask. You engaged in the parental protocol exchange, the PPE. Yeah.
Yeah, I'm slowly but surely discovering the levers to pull. Like last weekend, my
They must be
daughter.
teenagers.
It's great. Last weekend, my daughter actually did a really thorough job cleaning the whole house, and the only reason was she had a friend coming over the next day.
Yeah.
It's like,
Yeah.
I'm going to have your friends over more often.
That's right. Get on the calendar.
At least
Yes.
until the pain of tidying up
Exceeds
starts to exceed the embarrassment of a friend seeing it, you know.
That's lucky.
The
My kids don't care, so they'll just leave it whatever.
Yeah, I was going to say the PEF,
Gotta
the
find the
parental
right lens to
embarrassment
pull, right?
factor. Yeah. Excellent. Well, again, thanks for coming on, Ben. Good seeing you again. And to everybody
always.
out there in Coriolis land, we'll see you all on the next one.
Yes. Yeah. Thank you again, Matt. It's been great.
Yep. Thank you.
We'll look
Ben and-
forward to having